Hello everyone, welcome back to Root and Route and welcome back to the Rust for Hacker series. Today we are going to build a password cracker. I selected password cracker as a project for this part because we are going to learn in-depth threading and async tasks in Rust, and this is one of the best projects to do that because it is easy to start with a single thread. Then we explore how multi-threading, the OS threading can be utilized for this project. Then the same project can be converted to asynchronous task. Then again we are going to convert this to the semaphore design pattern. So that's why I selected this project. It will be compared to other projects, will be not, the complications will be there not on logic, but the complications will be there on the threading concept. So that's why I selected this one. Let us start with our project. Before going to that one, again, why we need a custom password cracker? The answer is very obvious because we have situations where the traditional password crackers like Hydra or any other tools that may fail, that supports online web cracking options. As an example, if you consider our same application that we were using, just say DVWA, and what we are going to do is we are going to crack from outside by using available passwords and usernames. So imagine this is a situation that we have to do this in Hydra. There is no chance to do. Why? Because this application has a dynamic nature. That means it needs something that normal password crackers can't crack. Nothing but it's just show you that. So what it's doing is it is fetching a user token, and it is using that user token when it's going to do the post request. So sorry, when we are going to use a traditional cracking application like Hydra, it doesn't have the facility to do the dynamic fetching of user token from my get request, then use the same token for submitting for cracking support. That's the reason that we are going to develop a custom web password cracker. So let us, I will show you how to use the Hydra first, and let me these options are, if you are not familiar with this one, these options are very simple. I'm saying Hydra to use the admin as my username, and fetch password from this dictionary list. And if you're using Kali Linux, your path may be different because I'm in Parrot, and Parrot has a path like this. Under dict folder, there is a common word list list that has the passwords. And I'm saying this is my domain, and this is going to be a post request, and the post request is going to be to this page, and you have to, these are the parameters for submission, username, and this is a placeholder that is going to replace with user with this one, and password with passwords from the list. And these are the other parameters. And here I'm just giving a dummy user token because there is no way to fetch the user token. So it doesn't matter even if you're giving a real token after checking the page. The application is handling that dynamically, so that dynamic nature can't be achieved using this one. So I'm just trying this here. I will show you. This is because I just tried before the demo. I tried it again and I closed it using Control C. That's why it was showing like that. And if you check here, it was trying different passwords. Even I think even if you try the real password, it will never pass it because of the user token that is using. I think it reached somewhere near password 2 because it's random checking, and passwords also tried. Even if it was password, the real password was there, it won't tell you it cracked it or not, because the way it is handling the user token is entirely wrong, because it is kind of static token for every post request, but the application is handling it in a different way. The application is handling it in a way that for every post request we need to fetch the user token before that. So we have to do a get request first, then we have to do a post. And we explain all these things when we are doing the web application scanner, and we will be using the some part of the codes from the web application scanner to do this. So let us start building our project. I'm going to name it as password cracker, and this is going to be, we are going to start with the single-threaded application. So then we do the transition from single-threaded to multi-threaded. That will be easier to explain and learn the new concepts of threading in Rust. So I'm just moving from here to the project folder and open and for this one I'm going to reuse some of the things from here. Yeah, we need the same dependencies, but here for the single-threaded application we don't need the Tokyo, so we remove that from the list. And one more thing we need to do is we have to add a feature called blocking from the request to do the single-threaded application. So it's not going to be asynchronous anymore. Here we start with the single thread stuff. So before doing anything, we are going to just make the request colon blocking client and use selector. What is scrapper? I'm going to copy this here. Use the scrapper. Do we need anything? Yeah, collections is fine, that we'll use later. So we are going to define our struct as say cracker, and client, we need client, and the base URL as string. Then we don't need the selector actually. Next we need is we can call password list, and it's going to be a vector string. So now we have these are the main things that we need to do the cracking. So the next thing is we are going to implement the cracker, define the function to initialize it. So the base URL, let it be like this one. We don't need to make it complicated when anyway, this the transition between the this and that will be easier. So for the cracker, it's going to return a cracker. So it's going to be a client, base URL and password list. Just say this is client, and the base URL is going to be, we will initialize the client. You have to initialize the client here. I think better we do that here. Let client this client is different from the client inside the struct, so we just say client not new, we have to build it, builder dot cookie store should be true because we need to keep the session. I think for this case we may need to just keep it true. This is not going to destroy our functionality, so I'm just keeping the session and build not unwrap. I'm going to say expect because unwrap is very unsafe. Fail to build the client. This one is fine, and now we are going to assign the newly created client to this one, and base URL is fine, the password list is fine. So the another thing I'm going to make change is instead of cracker I'm going to use self because that is a Rust provided way of referencing the same struct, and it's good because if in case if you are refactoring or renaming, so and if you're doing it manually, then maybe high chance that you may miss changing the name somewhere. So it's always good to refer this one. So the new function for initializing is ready, I think. This is fine. Now what we need, as we know, we have to fetch the user token. So anyway we need a user token fetching function that we already did, and this is not going to be asynchronous anymore here because it's going to be a single thread application. And let it be here, we just reuse the same code that we used in our web application scanners. So let it be here, the user token. And what else? Basically we need to do a brute force here, so we have to replicate the login function. So I'm going to copy this also and let it be here. Instead of login I'm saying brute force, and it's going to be self. Why is self means it's going to be a method of the struct, and this is going to be an not a struct method, even though the name is different as a function, but it's called associated function. I think that's correct. This will help us to initialize the struct, and these are the other functions that's called methods that you can call using this cracker struct. I'm saying login, and we need in this case actually we just need a username. We don't need a password because we are going to fetch the password in we are going to iterate through the list of passwords that already we have, and here in result type we are going to return, if password is found we are going to return true. And login to, instead of, we don't need this one anymore. The login URL is correct, and login page response we need URL then send. We don't need this await because we are going to use single threaded response, so it's not going to do the sync await here. Now we have the login page response that is going to get the token for us, and again no need of this one, async await here. And the next is login params. This is the thing that we need. Password is we don't have password here, so we have to do, what we have to do here is we have to put everything inside a loop because we are going to iterate over the password list. So for password in self self dot password list. We are going to do this here. Just cut it, and so here also we don't need an async await. Instead we are going to take the text here and propagate the result, and here is the main thing. Yeah, it says if login dot response is not login successful. I think the message is something different. Let us check that. So the response for this one is admin password. So the response is like welcome, or you can check enter stuff or just welcome. So if you see welcome in on the response, that means we crack the password. And yeah, it says the password cracking was successful with this one. And did I close the loop? Where is the loop? Oh no, I missed the loop. So this will exit the loop and return with this one. And since we have question marks here, so that will propagate the errors properly. So the next thing, I think it's better we say we are trying with the which password. Oh yeah, that is correct. And now, yeah, now the other thing is, if it is wrong, we say it is returning false. So that is done. I think this will work. Oh, but we need something. We need to pass a dictionary path to get the passwords. For that, I think it's better to define password fetching function outside this one. Just say get password list. Yeah, this will be I don't know whether this code, let us do it in a simple way. Let us say let mute password underscore list is a new vector. This may be correct, but let us do it in our own way, just not to make it complicated. So say let file equal to file open and file path propagate the question mark. That is better. And here instead of this, just say result, and the result is going to have vector string and this as the error. So we can use the question mark here instead of unwrapping it. So file, if and let the content of the file, the content should be say, we had to use another package called buffer reader, and buffer reader is going to help us to split up this one, and split up through the lines, and it would help us to fill it. So I think we need to add use std file. This, oh yeah, I think we need one more stuff called std buffer IO and buff read also. these two things are needed to do this operation. And is this correct now? Oh no, we are returning as a result, so we have to make it okay. And no need of comment. So yeah, we now have this one again having issue. Now we have these things, and I'm going to set the same for main function because we are going to call these things here. So what we have to do here, I'm going to either if you want, you can pass the parameter through the command line that we already did on multiple applications. If you have doubt on that, please refer the previous applications. But here I'm just directly going to mention my password file path. I'm going to say, not the password file, but I'm going to say passwords or password list, get password list. Here I can pass the list, and here in this one there's a, I think, cd ls user share dictionary. This folder has the file password files, and this file has almost all common passwords available. So I'm going to use that here. It is user share and dictionary, and this one, the question mark. So we get the password list, and then we initialize the cracker struct using this, but our path is different. Here it is DVWA, and we are passing the password list, and we are trying with the admin, and just say the result. And if everything goes fine, I think this will work, because logically it doesn't have any issues. We are iterating over the passwords, and if password found, we are returning the password, else it returns a false. Everything is result type, and it seems very good here. We take the terminal and build the application now. Cargo build. I think it's better if we add the timing for this one. That will be, because it will be better to know how long it is taking to find the password. Okay, we will do that. First let us try whether this is working or not, and after that we add the timing. Then later we move this to the multi-threaded application, then we compare this, the speed of that, then we go to the other one. And I'm not going to do everything into a single video, but why? Because it's going to be a bit complicated for you if you are looking into this learning Rust. So let us cd target and debug. Let's run the password cracker is trying these. Oh my god, I don't know that the list has password or not, or it is working or not. I'm not sure. Okay, let us wait for some time and see what is coming up with. Did it cover the password, the actual password? You may feel it is faster, but everything is working on a single thread. And let me see how much. it is I don't know whether is it because of my VS Code or this application is running, my memory is spike is happening and CPU reached 84. Okay, but before that let us check this path. Why? Just to ensure that the password is there. Oh no, it found yeah, the password, finally it found the password, but it did take, I think, a long time. Let us check the timing for this one. So for timing, where should we say? Before the loop we say let's start time equal to instant dot now. Then maybe inside once it finding this one, we say let duration equal to elapsed time, and we can print yeah, in this one and say duration dot as maybe seconds, you can say. This will work, I think. And in this case, if the password is not found, then let total time, the same elapsed here, password not found. Yeah, we can say okay, something like this, just to check the time. That's it. So here we are checking the elapsed time anyway. Now we know the password, actual the string is there. So after a long try, it did find it. So and just say cargo build again. We'll build it. We didn't make any big changes, and just say password cracker to see how long it is taking to find the password. So it's trying again. Now we have to find out the total time for the password. Maybe I don't know how long it is. I think it's more than 10 seconds. I think so. More than 10 seconds or 5 seconds. Anyway, it is taking much time. So the next challenge for us is to convert this to threading, OS threading, and we'll find out the timing, the time difference between the single threaded and multi-threaded. It's not yet done. Yeah, so I'm expecting more than 5 seconds, I think. Yeah, I think the system usage is getting higher. But this spike may be because the memory spike may be because of the Visual Studio, I mean the Codium that I'm using. This is taking too much of my CPU, and that's the reason I did restrict my Bubsuite's memory to 2 GB in this one, because Bubsuite was by default it was configured to use 50%. Yeah. Now, I think it did take 83 seconds. That is too much, in fact. We did convert that to seconds, right? Yeah. And we started the time here. The last time is too much. It's 83 seconds to find out a password from I think this list has maybe 20,000 lines. I'm not sure how long it is. But the other one that commonly available, the raw queue text, has more than that, I think. So if that text is going to be given, yeah, so that is definitely not good for a single thread application. So this is a problem of single thread application. This will work perfectly, but everything is going to be run in a single thread, and it is sequential, that there is no way that it is divided into multiple threads and every thread is trying the same thing. So that is our next thing, multi-threading. So before going to multi-threading, yeah, definitely is going to be the entire application structure is going to change, because we have to solve a little bit of problems there. One is that we want to try many passwords at the same time instead of one by one. So just imagine different threads are trying with different passwords, and the challenges in that one is when multiple threads run at the same time, every thread needs the client, the same base URL, and the same password to test. I missed that here. So, and other challenge is that when one of the threads is going to find out the password, we have to stop the other threads, and we have to inform the other threads that we got the password, so just stop the operation now. So that is going to create these are the problems that we are going to create, that we are going to solve. How do multiple threads going to use the same data, and how do they tell each other to stop? When we are going to convert this to the multi-thread application, definitely we can learn a lot of new stuffs, that especially the threading, the communication between the threads. Surprisingly, we are not going to use the channel mechanism for this application. There are some more advanced rusty way of doing that. We will be using those techniques to resolve our issue of passwords cracking here. So let us explore that in another video. I mean the next video. Probably that's going to be the next video in this series. So we will explore multi-thread. Then we will move to the async operations with the semaphore design pattern to control the number of concurrent tasks, those kind of stuff. I think after these 4 different scenario, from single thread to OS multi-threading, then to asynchronous task, then the semaphore design to control the asynchronous task. So when we cover all these 4 stuffs, definitely you'll get a clarity on how threading in Rust is working and some of the advanced forms of using in real-time applications. So see you soon with the multi-threaded application of the same. Till then, it's a bye from Root and Route. See you soon.